Impressive as that eruption is, it is just a hint of what's brewing right here in the U.S. Scientists have long known that Yellowstone National Park sits atop a huge supervolcano. But what they've discovered is that it's bigger than they thought. University of Utah researchers detected a vast pool of magma deep beneath the park, enough to fill the Grand Canyon 11 times over. Jeffrey Kluger is Time Magazine's senior science editor. Good morning, Jeffrey.
Good morning.
So tell me, this place that everyone goes to take selfies is really sort of like a ticking time bomb.
It is a bit of a ticking time bomb. This reservoir of magma, as you say, could fill the Grand Canyon multiple times over. If it blew, it would cover parts of 3 states, Wyoming, Idaho, and Montana. It could enter the jet stream and, as a result, ground air traffic in the same way the 2010 Icelandic volcano did. It could also cover the Earth with sort of a slightly sky-darkening blanket, briefly affecting climate. Think about the Mount St. Helens explosion in 1980, and now multiply that by 1,000.
It's been down there, Jeffrey, for 17 million years. We've just figured it out. So finding this, what does that tell us, finding this?
Well, first of all, it tells us how this volcano, the long-term life of this volcano, could be a very, very long-term life, because the deeper caldera feeds the higher caldera. So even if there was a smaller blast tomorrow and the top canyon was out of juice, the bottom canyon would simply fill it up.
I don't want to add more doom to doom, but I'm curious, do we now have a complete idea of exactly what's under the surface, or are we still, there could still be more?
No, we do have a complete idea, and the way they did this was very elegant. There are hundreds, even thousands of small earthquakes in that region in the course of the year. So with an array of 80 seismometers, researchers from the University of Utah sort of took I think of it as a subterranean CAT scan, because seismic waves move a little more slowly through hot rock than they do through cold. So when you analyze that, you suddenly got a complete picture of this enormous caldera beneath the ground.
There have been 3 giant eruptions in the past 2.1 million years, with the last about 640,000 years ago. I think I remember that one.
That's right.
But so when do we expect the next one?
Well, here's the thing. It's a fairly accurate science predicting when these things are going to blow, but only in the short term. We can say within a few weeks, a few months. But when you're predicting out to a scale of tens of thousands of years, that's different. Now, the next one should come within 60,000 years if this blows every 700,000. But the problem is 60,000 out of 700,000. We're in a misdistance of 9% here, so we could have some problems.
Will this new discovery lead to better estimates of future seismic and really just volcanic hazards?
It will, and it will for 2 reasons. First of all, because it helps us better prognosticate what's going to be happening or could happen in Yellowstone. It also provides techniques to look at other supervolcano sites around the world. The way I like to look at this one is this volcano is very unlikely to present a problem in your lifetime, in your grandchildren's, great-grandchildren's, unless it does.
So I shouldn't be worried walking around Yellowstone that the ground is going to...
Exactly.
Unless it
Not
does.
this week, anyway.
That's reassuring, Jeffrey.
Yes.
Thank you.